In the course of a game, WNBA player Cynthia Seifer shoots 12 free throws, denoting shots made by H for hit and denoting missed shots by M. Her results are as follows: H, 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 M, H, 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 M, 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 H. Use a .05 significance level to test for randomness in the sequence of hits and misses. Is your answer going to be A, test statistic G equals 5, critical values 3 and 10, reject H0. B, test statistic G equals 12, critical values 7 and 19, reject H0. C, test statistic G equals 5, critical values 3 and 10, fail to reject H0. D, test statistic G equals 12, critical values 7 and 19, fail to reject H0. Or E, test statistic G equals 5, critical values 4 and H, fail to reject HO. First of all, let's count up our numbers so we know what numbers we're dealing with. N1, N1, which is going to be our misses, our hits. Let's do our hits. Our H equals, how many H's do we have? It's like 1, 2, 3, 4, 5, 6, 7, 8. So we have 8. And our N2, which will be our misses, we have, let's see, 1, 2, 3, 4. So our N2 is 4. Okay. In order to start to solve this problem, we also need to look at the number of runs. And I've listed the definition. A run is a sequence of data having the same characteristic. The sequence is preceded and followed by data with a different characteristic or by no data at all. So let's look at our number of runs. We start out with H's. We have H, H, H. Oh, there's an M, so that's going to be a different run. We'll highlight the M in green. Then we have more H's. H, 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 H. We have some more M's. M, 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 M. Then we have another H. Okay, so we've highlighted all of our runs. So that gives us 1, 2, 3, 4, 5 runs. Runs is denoted by G here because G is the number of runs. That is our test statistic. So G equals 5. That's the number of runs. Okay. Now, we need to find the critical values. We've determined that G is 5, so we automatically know that answer B and answer D are not valid. Since N is less than or equal to 20, and N2 is less than or equal to 20, and alpha is 0.05, and the test statistic is G equals 5, we're going to refer to table A10 to find the critical values. Okay. Along this side here is N1. N1 we said was 8. N2 we said was 4. That's at the top. Now we need to follow our finger along, and 8 and 4 are right here. So that is how we find the critical values. And again, that is table A10. So we now have found our critical values. Those are 3 and 10. So I'm going to write that down. Critical values are 3 and 10. Okay, so now that we've determined the critical values are 3 and 10, we now know that choice E cannot be an option. So we're left with choice A or choice C. Both of them say test statistic G equals 5. Both of them say the critical values are 3 and 10. So now we have to decide, are we going to reject HO or fail to reject HO? Now, because G equals 5 is neither less than or equal to the critical value of 3, nor is greater than or equal to the critical value of 10, we do not reject randomness. So we are going to fail to reject HO. So there is not sufficient evidence to reject randomness. So because we are failing to reject HO, our answer here is going to be C. Fail to reject HO. Fail to reject HO. What we're saying is not sufficient evidence to reject randomness. Not sufficient evidence to reject randomness. And I will also circle the letter C.